Okay, so today we will be looking at what we call power series, and this is one of the great topic that we are looking at in this course. The idea of power series is really cool, but maybe some of you will not think it's cool. Yeah. I'm sorry. Oh yeah, I have more here. So what is a power series? A power series is a series n going from 0 to infinity, Cn times x minus a to the n. Cn's are called coefficients, and x minus a, the a in the parentheses is called the center of the power series, and so Cn's and a, they are constants, okay, and a series of that form is called a power series in x minus a. It's called a power series in x minus a. Sometimes we say that it's a power series about a, or around a, or centered at a. Okay, so there are many different ways of phrasing this. So a power series about a, centered at a, around a, or a power series in x minus a. The way you want to think of, you have seen polynomials, right? A power series is just an infinite version of a polynomial. So, for example, let's think about a polynomial where you have, let's say, half x plus 1 plus x plus 1 squared plus x cubed, right? What I'm saying is that if you have a polynomial, it means that you have powers of x, right? And a power series is basically an infinite version of a polynomial. Okay, so you have infinitely many powers of x. Am I making sense? Okay. For what values of, so when you have a power series, then if I have a power series, I am thinking of Cn's as given constants, okay? Cn's are given constants, and a is a constant as well, okay? So then I am asking, for what values of x is this series convergent, okay? For what values of x is this series, is the power series convergent? And in other words, if I set f of x to be the power series, then what I'm asking is that what's the domain of f? So if I am defining a function f, I am defining the function f as the sum of the series, right? As the sum of the series. So then I need to know what's the domain of the function f, which would mean that I need to know for what values of x is the power series convergent, right? For those values of x, there is a sum for the series, right? Is everybody clear that I'm defining the function f as the sum of the series? Okay. So I need to know the domain of f, and which means that I need to know what are the values of x for which the series is convergent. And let me write down the power series in the expanded form. So summation n going from 0 to infinity, Cn x minus a to the n. And so what's the first term of the series? The first term of the series is C0, right? Because then you get n to be 0 in the exponent. And what's the second term? The second term would be C1 x minus a to the 1. What's the third term? C2 x minus a to the 2, right? And so on. So basically you are getting powers of x minus a, right? Remember, a is fixed. So you get powers of x minus a. In other words, you're getting powers of x, right? So you're getting infinitely many powers of x, basically. Is everybody okay? So that's why I'm saying that you can think of this as an infinite version of a polynomial. Okay. Now, notice one thing though is that remember we set f of x to be the sum of the series, right? We defined f of x to be the sum of the series. And first of all, notice that if I look at f of a, remember a is the center of the series. Is the series convergent at a? Is this series convergent at a? When x is a, do we get a convergent series? That would be the value of the function at a. So what is f of a? F of a would be c0 plus c1 times what? A minus a, right? Plus c2 times a minus a squared, and so on. Notice that I get all the terms after the first guy are 0. So all I get is c0, which means that when x is a, the series is convergent, right? Because you have c0 and 0, 0, 0, 0, 0. So that's the convergent series. And so f of a is the same as c0. The value of f at a is exactly c0. So we see that f of a is defined, or the series is convergent at a. So anytime you have a power series, there is at least one value of x where the series is convergent, right? In a power series is always convergent at the center. Okay. Let me give you an example of a power series. Let's think about the power series given by summation n going from,
Is the center of a power series a or negative
a? If you have x plus a instead of x minus a, then the center will be negative a. Okay, so you have the summation n going from 0 to infinity x to the n. And is that a power series? What are the coefficients Cn here? And what's the center here? What's the center here? You have x to the n, right? Can I think of that as x minus 0 to the n? And the coefficients are what? All the coefficients are 1, and the center is 0. So this is a power series centered at 0. Okay, this is a power series centered at 0. Now obviously this series is convergent at 0, right? What's the sum of the series at 0? 1. And if you think of this series, this should be a familiar series, right? This series, is that a geometric series? Well, look at the ratio of any term to its previous term. You get what? If you divide any given term by the previous term, what do you get? X, right? You divide x cubed by x squared, you get x. You divide x squared by x, you get x, right? So that's the common ratio of the geometric series. So here the ratio r would be x. And what is the first term of the geometric series here? 1. So a should be 1. So if I use remember we have this formula for the sum of the geometric series, right? A over 1 minus r, where r is the common ratio, a is the first term, right? So then the series n going from 0 to infinity of x to the n, that series we know exactly when it's convergent, and we also know exactly the sum. So what is the value of this series? Well, when x is between -1 and 1, we know that the geometric series is convergent, right? When r value is between -1 and 1, r is x here. So when x is between -1 and 1, we know that the series is convergent, and the sum is given by what? A over 1 minus r. So this would be 1 over 1 minus x. And then we know that the geometric series is divergent otherwise, right? The geometric series is divergent otherwise. That is, for x bigger than or equal to 1, the series is divergent. So when we have a power series, once we determine the values of x for which the series is convergent, the power series is convergent, those values of x will be called the interval of convergence. So in this case, what's the interval of convergence? The interval of convergence is the interval from -1 to +1, okay? That would be the interval of convergence. These are the values of x. So what do I mean by the interval of convergence? Values of x for which the power series is convergent, right? And then when you will see that the interval of convergence is always an interval. For a power series, if it converges, either it's going to converge at only one point, or it's going to converge on an interval centered at the center of the series. Okay. So remember, 0 was the center of this series, right? 0 was the center, and the interval of convergence is centered at that 0, right? The interval of convergence is centered at 0, and that was the center of the series, right? The way we define center. So here, another quantity that we need to recognize is what's the radius of convergence. The radius of convergence here is 1. Okay, so what's the radius of convergence? That's look at the interval of convergence, right? The length of the you look at the distance from the center of the interval to one of the endpoints of the interval. So that length is the radius. So again, the radius of convergence, look at the interval of convergence, look at the distance from the center of the interval of convergence to one of the endpoints. That distance is the radius of convergence. So for this series, the radius of convergence is 1. The interval of convergence is from -1 to 1. Notice that the interval of convergent is centered at the center of the series. And the sum of the series is given by 1 over 1 minus x. Yeah?
Will we ever have a case where the interval of convergence would be like -3 to 1, and then the radius would either be 3 to 1?
Well, if you have -3 to 1, okay, if you have, so what he is asking, suppose you have an interval convergence from -3 to 1. If that happens, what's the middle point here? -3. What's the middle number here? -1. So that would be the center. That would be the center of the series. We'll see in a bit that if you have the interval of convergence, so the center of the interval of convergence is always the center of the power series. So what's the radius of convergence here? 2. Okay, the radius of convergence, by its definition, is positive. Okay, but there is one case when the interval of convergence is basically the entire real line. In that case, we are going to say that the radius of convergence is what? Infinity. So we'll see an example of that in a bit. Okay, is everybody okay with this example? Let's look at another one. Suppose that the question is find the radius and interval of convergence of this series. So this is a good exercise on the ratio test as well. So ratio test will play a big role in this section. So how do I come up with that? Well, I am going to first of all I'm going to say, I'm going to name the nth term. I am going to name the nth term, let's say an. Okay? And then I want to look at the limit. If I want to use the ratio test, I need to look at the ratio of an plus 1 divided by an, right, in absolute value. And then I take the limit as n goes to infinity. I will write an plus 1 divided by an. Okay, so then what is an plus 1? An plus 1 would be what? Can someone tell me that? What is an plus 1? Go ahead. X minus 4 raised to the n plus 1 divided by what? Very good. And then divided by x minus 4 to the n over n. Don't forget the absolute value sign. And now we can rewrite this. We can turn the we can transform the division into multiplication by flipping the ratio, right? So this would be x minus 4 to the n plus 1 over n plus 1 multiplied by n over x minus 4 to the n. What can I cancel out? What can I cancel out? So this will be the limit. Go ahead. Yeah, so first of all, let me write n divided by n plus 1. There is nothing I can cancel out there. And then between x minus 4 to the n plus 1 and x minus 4, that's going to reduce to what? Just x minus 4 to the 1, right? And I still have the absolute value sign. So this would be the limit as n goes to infinity, n divided by n plus 1. Do I need absolute value sign on that? No, because n is positive, so the ratio is positive. However, I need to put absolute value sign around x minus 4. Are we okay? Alright, so now what's the limit? Can someone tell me what the limit is? So this limit is equal to what? Notice that x minus 4 does not depend on n, so I can take it outside of the limit. You guys are okay with that? X minus 4 does not depend on n, so it's not affected by the limit as n goes to infinity. So what am I getting then? What's the limit of n over n plus 1? 1. So I get the limit is exactly x minus 4. Now, we are applying the ratio test, right? So by ratio test, so what did I get so far? So the limit as n goes to infinity of an plus 1 over an in absolute value is equal to absolute value of x minus 4. And what do we know from ratio test? We know that two things, right? We know that if this is if it is strictly less than 1, right? Strictly less than 1, then absolutely convergent. And if it is strictly greater than 1, then divergent, right? But unfortunately, the ratio test doesn't tell me anything what happens when this is exactly 1. When this is 1, then the test ratio test is inconclusive, right? Ratio test is inconclusive. So we have to do something about that, but so far let's see what we have. So x minus 4, if x minus 4 is less than 1, if the absolute value of x minus 4 is less than 1, what does it mean? It means that x minus 4 is less than 1, greater than negative 1, right? Is everybody okay? So what does it tell you? It tells you that x is between what? 5 and 5 and you're adding 4, right? 5 and 3. So we are basically saying that our interval of convergence is the following. Here I have 3. Let's say here I have 5. Okay. What's the center? 4 is the center. Remember that our series, what's the center of the series? The center of the series is 4, right? X minus 4, and the center of the interval of convergence is the same as 4. Now, so far we know what? So far we know that we have the interval of convergence is between 3 and 4, but we still don't know. We still don't know what's happening at 3 and what's happening at 5. Why? Because imagine that imagine that we already know from the fact that when the absolute value of x minus 4 is greater than 1, right? Then we know that the series is divergent. So I know that outside of the interval from 3 to 5, the series is divergent, right? Outside, so when the absolute value of x minus 4 is greater than 1, what are you going to get? What are the values of x for which absolute value of x minus 4 is greater than 1? The values of x for which absolute value of x minus 4 is greater than 1 would be where? Would be here and here, right? Outside of the interval from 3 to 5, right? Outside of that interval, the series will be divergent. Okay, I know that. However, when absolute value of x minus 4 is exactly 1, when? Absolute value of x minus 4 is exactly 1 when x is either 3 or 5. When x is either 3 or 5, absolute value of x minus 4 is exactly 1. Which in that case, ratio test does not help me, right? So I actually, at this point, I don't know whether the series is convergent or divergent at 3 and 5. Is everybody okay? So far I know that the series is convergent between 3 and 5. Outside of 3 and 5, the series is divergent. But what happens at 3 and 5? Well, unfortunately, the ratio test doesn't help us, so we have to do the following. We have to look at those cases separately. So when I take x to be, let's say, 5, right? What series do I get? When x is 5, the series that I get is what? N going from 0 to infinity. 5 minus, so I'm going to plug in 5 for x, right? 5 minus 4 to the n divided by n. So what series do I get? 1 over n, right? So this is the series summation n going from 0 to... oh, you know what? I made a mistake here. It should be 1 to infinity, okay? The series, I mean, clearly it doesn't make sense at 0, right? Oh, I wrote 0 again. 1. Okay, so n going from 1 over n. Is that convergent or divergent? Divergent by p-series test, or this is a harmonic series, right? So first of all, I know that when x is 5, the series is divergent. So in my interval of convergence, at 5, I should have a hole, right? 5 is not included. Now, how about when x is 3? When x is 3, what do I get? So I'm going to make 5 to be a 3. And this 5 would be a 3. And then what I'm getting is negative 1 to the n, right? Is that convergent or divergent? This is by alternating series test. This series is convergent, right? So what am I getting then? What am I getting is the following. I know that the series will be convergent at 3 and it will be divergent at 5. So what's the interval of convergence then? The interval of convergence would be closed at 3, open at 5. The radius of convergence is 1. That's the distance from the center to the end point of to one of the endpoints of the interval. Okay, so that's what we get. Is everybody okay with that example? Yeah. The radius from the center of the interval to one of the endpoints. What's the distance? The distance between the center and one of the endpoints. That's the radius. Or basically, whatever the length of the interval of convergence is, you divide that by what? 2. Yeah, half of the length of the interval. Yeah. Outside of 3 and 5, the series is divergent, so they will not be included in the interval of convergence. Is everybody okay? So what I said again, if you look at the values of x outside of the interval from 3 to 5, for example here, absolute value of x minus 4 would be greater than 1 here, and also absolute value of x minus 4 would be greater than 1 on the left side of 3. Okay? So those are the places where by ratio test we know that the series would be divergent. Okay, let's look at another example. Let's say I have the series n going from 0 to infinity, n factorial times x to the n. So this is a power series. What's the value of Cn here? What are the coefficients? Well, the nth coefficient is given by n factorial, right? What's the center of this series? What's the center of the series? What is the center of the series? 0. It's again, the center means here I have n factorial times x minus 0 to the n, right? So 0 is the center of that series. Now we are going to apply the ratio test again. So let's take an to be the nth term of the series. So n factorial times x to the n, and then we look at the ratio of an plus 1 and an. If I take the ratio of an plus 1 and an, what do I get? I get an plus 1 would be n plus 1 factorial times x to the n plus 1 divided by n factorial times x to the n. And then if I simplify this, n plus 1 factorial, remember, is the same as n plus 1 factorial is the same as n plus 1 multiplied with n factorial, right? So what I'm saying here is that if I look at n plus 1 factorial, that's the same as what? N plus 1 times n times n minus 1 all the way up to n. But if you look at n up to 1, what is that? N up to 1 is n factorial. So that's why I can write n plus 1 factorial as n plus 1 times n factorial, and then I can cancel out the n factorials, and x to the n plus 1 over x to the n will reduce to what? Will reduce to just x. So then I could say that the ratio of an plus 1 and an is exactly absolute value of n plus 1 times x, which is the same as n plus 1 times the absolute value of x once I take the absolute values. Is everybody okay so far? Any questions so far? No? Okay, so now I take the limit. So if I take the limit as n goes to infinity of the ratio, I would be getting the limit as n goes to infinity of n plus 1 times absolute value of x. So what is this limit? Well, notice that if x is 0, then the limit would be 0. However, if x is not 0, if x is negative 1 or negative 5 or 2 or 3, whatever, if x is not 0, then within the absolute value I have just a positive constant. As n goes to infinity, n plus 1 goes to infinity. So the whole thing will go to infinity. Right? So if x is 0, then the limit is 0. Otherwise, the limit is infinity. Okay? So what does that mean? Well, it means that in this case for any value of x for which for any non-zero value of x, the limit is not less than 1, right? It's greater than 1 or it doesn't exist. And so the only ratio test tells me what? The ratio test tells me that this series will be convergent when x is 0, right? This series will be convergent, absolutely convergent, at the center, x equals to 0, and otherwise it will be divergent, right? Because the limit is greater than 1 when x is non-zero. When x is non-zero, the limit is greater than 1, so the series will be divergent for any non-zero x. So what's the radius of convergence here? Because the series only converges at 0, right, the radius of convergence will be 0. And what's the interval of convergence here? 0 to 0. I mean, it means that the only value, there is only one value of x where the series is convergent. Is everybody okay? Any questions on that example? Did that make sense? Did that make sense? Okay, so let's look at another example. Suppose I have the series n going from 0 to infinity, x to the n divided by n factorial. So in this case, again, what's the nth term? The nth term is this guy. So that is my nth term. I take the ratio of an plus 1 and an. If I take the ratio, what do I get? Well, absolute. So I'm taking the absolute value of the ratio. So it's going to be absolute value of x to the n plus 1 divided by n plus 1 factorial, and that's going to be divided by x to the n over n factorial. And then I can turn the division into a multiplication, and then I get x to the n plus 1 over n plus 1 factorial times n factorial over x to the n. And then I can reduce it, right? Let me write one more step here. First of all, once again, x to the n plus 1 and x to the n, right? They reduce to x. And then I have n factorial with it. In the denominator, I have n plus 1 factorial, right? And that can be written as what? N plus 1 factorial is the same as n plus 1 times n factorial. So when I cancel out the factorials, I end up with what? I have a typo here. This should be what? N plus 1. Okay. And now, so that's the ratio. So what's the limit as n goes to infinity? So if I take the limit as n goes to infinity of the ratio of absolute value of the ratio of an plus 1 and an, I get the limit as n goes to infinity of absolute value of x divided by n. Now absolute value of x does not depend on n. I can take it outside of the limit, right? And then I get absolute value of x times the limit of 1 over n. But the limit of 1 over n is what? 0. So what am I getting then? Well, I am getting that the limit is 0 no matter what x is, right? No matter what x is, the limit will be 0. So for any x. So we have that, let me know if you're done writing this down, then I'm going to move on. So far what we have is that the limit of the absolute value of the ratio of an plus 1 and an is 0 for any x. That's important, for any x. So what for any x it's 0. So is 0 less than 1? 0 is less than 1. Okay. And so what I have then is that the limit as n goes to infinity of an plus 1 over an is 0 for any x. So by the ratio test, the given series, power series, is convergent for any x. So what's the interval of convergence here? What's the interval of convergence? Negative infinity to infinity. What's the center? And what's the radius? Infinity. So interval of convergence, negative infinity to infinity, and the R value is infinity. Now think about the 3 examples I did. Why did I do 3 examples? I could have done just 1 example. Well, I wanted to show you that there are 3 cases that happens. When you have a power series, right, there are 3 things that can happen. 1, the series converges for all x, which is my 3rd example. Series converges for all x. My 2nd example was the series converges on a finite interval, right? It's an interval. And then the 3rd case was the series converges only at 1 point, right? That was my 2nd example, sorry. 2nd example was the series converges only at 1 point where the radius of convergence was 0. And the 1st example was where the radius of convergence was finite number what? 1, right? So three cases that happens when you have a power series. And my next theorem tells you that. So here's the fact. I gave you that theorem in the in my handout. So suppose I have a given power series n going from 0 to infinity, Cn times x minus a to the n. For this given series, exactly one of the three possibilities will occur. For a given power series, exactly one of three possibilities will occur. The word is exactly, okay? Exactly one of the following three possibilities occur. What are they? The series converges only when x is the same as the center. Remember, a is the center. So the series converges only at the center. That's one possibility. Second possibility is that the series converges for all values of x. What's the radius in this case? What's the radius in this case? 0. What's the interval of convergence? A to A. Right? Second case, the series converges for all values of x, right? For all values of x. So what's the radius here? The radius here is infinity in that case. And then what's the interval of convergence? Negative infinity to infinity. And the third case is there is a positive number r such that the series converges for all values of x, satisfying x minus a, absolute value of x minus a less than r. In other words, x is between a minus r and a plus r. And the series diverges when absolute value of x minus a is bigger than r. So in this case, what's the picture? Oh, I have the picture here. So what we are saying is the third case means that there is a positive radius r, capital R, such that the series converges on an interval centered at a of length 2r, for example. And so the yellow portion is the interval of convergence. We know that the series will be divergent here. So this is where absolute value of x minus a is bigger than r. Here, absolute value of x minus a is bigger than r. And in the yellow portion, absolute value of x minus a is less than r. Okay? The third possibility is that you have a positive radius. Okay? Positive radius. Again, the interval of convergence will be always centered at the center of the series. Okay? So these are the only three possibilities that can happen for a power series. Any questions, anyone? Any questions at all? Please ask, because this is my favorite problem to ask. Okay, for future exams. Okay, so if you want, if you have any questions on this, please let me know. Okay, what I meant to say that one problem like this will be on the exam, right? Do I need to be any more obvious than that? Okay. Which case? I won't tell you that. I mean, it doesn't matter which case happens, because all of them are pretty much the same. You apply the ratio test, and you determine where the series converges and where the series diverges. Okay. Any questions at all? Everybody's okay with that? All right. So if you are okay with that, then let me do another example. So remember this series that I saw, the series n going from 0 to infinity, x to the n. And this is a power series centered at what again? Yeah, this is a power series centered at 0 where all the coefficients are basically 1. And that's basically the series 1 plus x squared plus x cubed plus ... So I know that this is a geometric series basically, right? In x. X is the common ratio. So what do we know about this guy? We know that this series n going from 0 to infinity of x to the n is 1 over 1 minus x for minus 1 less than x less than 1. So when x is between negative 1 and 1, that's the sum of the series. And divergent otherwise, right? Divergent else. So for any other values of x, this series is divergent, right? So what are we saying here? If you think about it, what I'm saying is that this function that I have, 1 over 1 minus x, right? That's a function, right? That's a familiar rational function. We are saying that that function is the same as the value of the series, right? The sum of the series. The sum of the series is the same as the function 1 over 1 minus x, right? As long as x is between negative 1 and 1, right? Otherwise, it doesn't work. So the value of the function 1 over 1 minus x is the same as the sum of the series, right? That's what I'm saying. As long as x is between negative 1 and 1, but if x is outside of that interval, then that equation doesn't hold. Is everybody okay? So I'm going to think of this as the power series representation. So think of this series as power series representation of the function 1 over the function 1 over 1 minus x. Am I making sense? Because the value of the function, power series representation of the function for x between negative 1 and 1, okay? So at least we can express the function 1 over 1 minus x as a power series as long as x is between negative 1 and 1. Otherwise, we cannot express this function as a power series. Am I making sense? Now, you know that the polynomial functions are nice functions when it comes to taking derivatives and integrals, right? So people then thought, well, if you have a power series, you will see that it's easy to take the integral and derivatives of power series functions. So given a power series, I can think of that as a function, right? I can think of the domain of that to be the interval of convergence, right? And the question then people ask is, can I express a given function as a power series? That is, for example, the exponential function e to the x. Can I express that function as a power series? Can I express the sine x function as a power series? Can I express the cosine function as a power series? Can I express the log function as a power series? And the answer is, in many cases we can. And what's the good thing about it? Well, think about e to the x as a power series. If you can express e to the x as a power series, that gives you a way to estimate the values of e to the x, right? How do you find e to the power half? How do you find e to the power 2? How do you find e to the power 0.1? How do you do that? Calculate. But how does the calculator know what to do? Well, the answer is, you can express e to the x as a power series, right? So what would be e to the 2? So what happens is that I can express e to the x as a power series, in fact, x to the n over n factorial. We are going to show that We're going to show that, prove that next time. E to the x can be expressed as a power series, and this is for any x. For any x, the sum of the power series is the same as the value of e to the x. Remember, this was my third example, right? This series was my third example. We saw that this series converges. What's the interval of convergence for this series? We did this today. The interval of convergence for this series is all real numbers, right? So this power series, okay, is the sum of the power series is the same as e to the x. Why is that good? Well, if you want to know what is e to the power 1.1, what would you do? You're going to plug in 1.1 for x and going from 0 to infinity, right? Now, you cannot find the exact sum of the series. What do? Well, depends on how much accuracy you want. Depending on how much accuracy you want, you need to add maybe the first 100 terms. Right? If you add the first 100 terms, let's say, you're going to get an estimate for e to the 1.1 up to certain accuracy. Am I making sense? Remember, we did these problems where we wanted a specific accuracy and we determined how many terms do I have to add to get that accuracy. So we can estimate the value of e to the 1.1 by using the power series representation. By adding finitely many terms of the series, I can give an estimate for e to the 1.1. And that's exactly what the calculator does. Okay? Alright, so we will see 11.9 tomorrow, okay?